Today I am building these 2.5-way stand mount speakers with compression driver and horn. This project started off after doing some research on horns. I have never really built a speaker with a horn, and thus I wanted to start with a smaller project. However, I also already have some larger horn projects in mind, but that I will leave for future discussion. The enclosure is relatively small, only 307 millimeters high, 145 millimeters wide, and 336 millimeters deep. The horn with compression driver sits on top, and I rather like this open industrial look compared to having the horn built into the enclosure. It is just visually more interesting and can be a bit of a conversation starter if you opt to build these yourself. That said, I will have comprehensive build plans for this project available for purchase on our web shop at soundblab.net. There's a link in the description of this video. This is a 2.5-way design with 2 woofers per enclosure. The drivers chosen are the BNC DE258 ohm compression driver mated to the ME20 horn, also from BNC. This horn provides a 90-degree vertical and 60-degree horizontal dispersion pattern. The woofer are 2 Dayton Audio TCP 115 4-ohm drivers in a 2.5-way configuration, and these can go fairly low considering their size, with a -3 dB point of around 42 Hz in this enclosure. Having cut all the panels for the enclosure, glue up from 18mm or 3/4 inch MDF, the assembly can start. This is basic butt joints with wood glue and securing with brad nails. Inside is a brace panel with 3 large holes for airflow inside the enclosure and to help eliminate cabinet resonance. Holes are cut for the two woofers in the front baffle. The driver flanges are relatively shallow, and I opted not to flush mount the drivers to make this easier. The rear of the driver holes are beveled with a 45-degree router bit to allow the drivers to breathe a bit easier in the enclosure. I 3D printed this template to help me cut the holes for the terminal cup and the port. This I can then also use in the future again to make the process easier. I cut out the majority of the hole with a jigsaw and then used the router with a flush trim bit to cut the holes according to the template. I will provide the STL file for download in the description below. Before I apply the finish to the enclosure, I make sure to fill all the holes and gaps with wood filler. Unfortunately, I did not film the finishing process of this project, but you can see the same process followed in one of my previous videos. The corners of the enclosures have a slight 1/4 inch round over, and even though this does not really make a big difference in terms of avoiding diffraction, it does soften the look slightly. The compressor driver with the horn is mounted on top of the enclosure with the aid of a 3D printed bracket. You can also make this bracket from 1/2-inch plywood or similar if you do not have a 3D printer. Details for this will be in the build plans. For now, I am test fitting the horn and the tweeter binding posts so that I can take proper measurements for the crossover modeling. A final mounting of these parts will happen after the enclosures have been finished with paint. The enclosures are finished with a water-based high viscosity enamel paint, and apologies but I did not film this. However, if you watch one of my previous videos, you'll see some of this process there. Once the paint is dry, I am fitting the compression driver with horn and mounting bracket and the tweeter binding post to the top panel of the second enclosure. The woofers are also pre-fitted so that I can pre-drill the mounting holes for them. The crossover is fairly simple, however there are some high value capacitors which does add up to the cost of this build, but it was certainly worth it considering the performance of this little speaker. More on that later. We have an L pad on the tweeter to reduce the level in line with the woofers together with a second order filter and a second order filter on the top woofer and a simple first order on the bottom woofer for a classic 2.5 way speaker design. The frequency response is looking very good with a crossover point between the top woofer and the tweeter at around 1800 Hz. The impedance is at its lowest just above 4 ohms, and I would suggest the speaker is most likely best to be used with a solid state amplifier that can handle a 4 to 8 ohm load. The crossover is built on a 6mm MDF board. The parts are laid out and then I drill 6mm holes to secure the parts with cable ties. The connections between the components are soldered point to point with speaker wire used where some component leads do not reach each other. The board is fairly narrow for such large components, so I was limited in the way I could place the parts on the board. In addition to the cable ties, you can also use some hot glue to further secure the parts in place so that they do not move around on the board over time. I am using a 3D printed port, but I will also specify an off-the-shelf port that can be adjusted to the specified length in the build plans if you are not able to 3D print this yourself. After the port is installed, polyfill or Dacron is stuffed around it to fill up the top half of the enclosure before mounting the top woofer in place. Once all the wires have been soldered to the crossover, it is placed inside the enclosure through the bottom woofer opening. You can use some double-sided tape on the bottom of the board to secure it in place, and then fill around it with more polyfill or Dacron before mounting the bottom woofer in place with screws. The terminal cup can now also be soldered to the power wires and fixed in place. The 3D printed tweeter bracket is secured to the top panel with M6 machine screws, and the compression driver and horn to the bracket also with M6 machine screws. The tweeter is connected to the binding post with speaker wire, and finally I 3D printed 4 caps to close up the holes in the horn for a better look. This loudspeaker provides ample low-end bass and has a definite punch that you can feel in your chest at higher volumes. Thanks to the low crossover frequency of the horn, we get a very smooth and non-fatiguing mid-range and top end. The sound is dynamic, and with the right music and correct placement of the speakers in your room will give good soundstage and imaging. I like these a lot, and I can't wait to try another horn build. Keep a lookout for another upcoming horn project. Thank you for watching. Please support me further on Patreon and YouTube membership, and subscribe if you have not done so before. Also give this video a thumbs up. I will leave links to all of this in the description below. But let's play a sound demo, and until next time, adios. Something in my brain causes stress, so come on, make me feel different. You wanna hold, don't hold back. Oh, your little drama's got me mad, and I don't need to tell you facts. You know I always want you back, girl.
I'm sick and tired of contemplating. I don't wanna be here waiting. If this is love, then I don't want it. I can't be the one you keep running to whenever you feel down. I can't be that someone who'll always be there when something's wrong. I can't rely on you now. I can't rely on you anymore. I can't depend on you now. I can't rely on you.
Di el tiempo que no tenía por errores que soñas, sino de noche, de día, si no pregunta tu almohada, por los gritos que escuchaban los vecinos. Te trago pero qué rico se vino, agua dulce baby, puro manantial. Nos comemos y se volvió personal. La baby no es bien pero le doy 10. Le quito el sostén.
The gentle April rain that stained the window panes last night is all but gone, but lingers on in scented clouds of air. We watch the town awaken to the trembling